Today we are looking at the Maths Home Learning Pack, and this lesson we're focusing on is week 7 day 3 and it's based on angles. Before we get into lesson, there's just a couple of things we need to remember. So a straight line is made up of two right angles. A right angle is 90 degrees and a straight line is 180 degrees, which is also the angles in a triangle. So if we're going to find a missing angle on this straight line here, what we could do is take 180 degrees, because we know that the angles on a straight line add up to 180, and then take away the angle we have been given. So for this one we would do 180 take away 39 to find this missing angle. So the first question we're going to look at says, Jen says if I turn from 2 o'clock to 8 o'clock, this is a half turn, 180 degrees. So we're turning from 2 o'clock to 8 o'clock, and she says it will be a half turn or 180 degrees. Is Jen correct? Prove it. What other turns can you identify on a clock face that will be the same value as 180 degrees? So as I've just mentioned in the first slide, we know that 180 degrees is the same as a straight line. So we want to see whether a turn from 2 o'clock that finishes at 8 o'clock would be the same as half a turn, which will also create a straight line on my clock down here. So using my straight line tool, all I'm going to do is first mark on 2 o'clock. That's where Jen starts. There's 2 o'clock. And then she finishes at 8 o'clock, so she starts at facing towards 2, turns towards 8, she would end here. As you can see from these lines, Jen has turned 180 degrees because we have created a straight line on the clock. We have also split the clock in half. Now the angles in a circle add up to 360 degrees, and half of this is 180, so she is correct. She would turn 180 degrees from 2 o'clock to 8 o'clock. Now to look at other turns that we could identify on our clock face that would be the same value as 180, all we need to do is find different ways of splitting our clock face in half. So for example, if she started facing towards 3 o'clock, she would have to turn to 9 o'clock to make that a half turn, and then one more if she started at 6 o'clock, she would have to turn to 12 o'clock to make that a half turn. This question gets a little bit trickier, that's why I've included it here. So we're going to calculate the missing angles on this picture and explain how we work them out. Now, if you are approaching this, you could take one look at it and think, oh my goodness, I don't know where to start. So we're going to take it bit by bit and see which parts we can work out first that will then help us work out the other missing angles. So I'm going to start with A down here. I've said previously that we know that the angles in a triangle, the internal angles, add up to 180 degrees. Now we already have two angles in this triangle. We've got 80 degrees here and 50 degrees here. So to work out A, what we need to do is do 180, which is the total angles, take away 80, then take away 50, and that would give us A. To make my working out easier, what I'm going to first do is add up 80 and 50. So we're going to do 80, add 50. Well, I know that 8 add 5 is 13, therefore 80 add 50 is going to be 130. So I know that in my triangle I already have 130 degrees, but I want 180. So that means A equals 180 take away 130. If I count on from 130 to 180, 130, 140, 150, 160, 170, 180, I know that there are 50 degrees remaining. So angle A is 50 degrees. Next, I'm going to work out angle C here. I can see that angle C sits on a straight line with this 50 degrees here from this triangle. Therefore, what I can do to work out angle C is take 180 and take away 50 from that. So C would be 180, take away 50, and I know that equals 130. Therefore, angle C is 130 degrees. Now I'm going to look up here at angle D. Angle D, I have noticed, sits on a straight line with this angle 80 here from inside the triangle. Therefore, to find D, I'm going to do 180, take away 80. So 180, take away 80, and that leaves us with 100 degrees. So angle D is 100 degrees. And then finally, I have noticed here angle B. Angle B sits on a straight line with angle D here, which we've just worked out to be 100. So I can do 180, take away 100 to get angle B. So 180, take away 100 equals 80 degrees. Therefore, angle B is, oh, that's not right. Angle B is 80 degrees. So there's some patterns that we could also have a quick look at here before we move on to the next question. We've noticed here, I've noticed, that these angles here are the same. This is because this triangle is an isosceles triangle, and in an isosceles triangle, two of the angles are the same and then the other is different. That also means that these sides are the same length. And here I have noticed that around this point, this angle here 80 is the same as the opposite angle here 80. Therefore, angles around a point, the opposite angles are equal. Therefore, this side would be 100. And angles around a point, that creates a circle that would add up to 360 degrees, and I could check this by adding 100, 100, 80 and 80, which does add up to 360 degrees.